So here's the first Pythagorean theorem example. We have 2 points, and we are to find what is the distance between these 2 points. So here is the distance we're looking for. I'm going to call it D for distance. Okay? Now at first it looks like there isn't anything we can do here. I suppose I could bust out a ruler, but I don't know what the scale is. So instead, what I'm going to do is I'm going to make a right triangle with sides that I know. I have this tiny right triangle here, and this bottom side is how many units? Well, it goes from -6 to -3, but we could just count 1, 2, 3. And up this side is 1. And now that we've turned this into a right triangle, we can apply the Pythagorean theorem. So we're going to say that 1 squared plus 3 squared must equal D squared. Well, let's see. 1 squared is 1, 3 squared is 9, 1 plus 9 is 10, which is D squared. And remember, to undo a squared, we square root both sides. So it looks like D is the square root of 10. Let's see, is there any way that we can simplify that? 10 is 2 times 5. Nope, does not look like we can simplify that. So we're just going to leave it as the square root of 10. Now, just because I know some of you are itching to grab that calculator, I will go ahead and give you a decimal approximation using my calculator. Let's see, the square root of 10 is about 3.16. But I really want you to be able to work with those square roots. Okay, so now that I've done one for you, here is a second example of a similar sort of problem. Once again, we have 2 points. Please find me the distance between these 2 points, which is this distance right there. Please go ahead and pause the video. I really do want you to try this on your own. There is nothing like getting the right answer yourself. Ready, set, go. All right, so we're going to build a right triangle. Now, last time we built the right triangle underneath, but it doesn't matter which way you go. So I'm actually going to make my right triangle look like this. There, and there. Still works, right? It's still a right triangle. The blue side of this right triangle looks like it's 2 units long. The red side of this triangle looks like it's 1, 2, 3, 4, 5, 6, 7, 8, 9 units long. So now we can set up the Pythagorean theorem. When 2 squared is 4, 9 squared is 81. That means that D squared is 85, which makes D the square root of 85. Now let's see here. Square root of 85. 85 is 5 times 41. And 41 is actually prime. So we're done. Square root of 85 it is. Hey Google, is 41 a prime number?
Yes, it's a prime number.
Just checking. You never know. I've been wrong before. Moving on. Here we've got a zip line that starts on a platform that is 40 meters above the ground. The anchor for the zip line is 198 meters from the base of the platform, so this is approximately a 2 football field zip line. So that's pretty great. So the question is, how long is the zip line? So our distance, d, is right there. Once again, please take a moment, pause the video, see what you can do. Ready, set, go. So I'm going to go ahead and set up and solve the Pythagorean theorem very quickly here. I assume by this point you're all beginning to get this, so I'm going to go ahead and just speed through this problem. So we get that the zip line is 202 meters long. So again, this is an idea that you kind of already know. For example, if you're walking on a path, and the path goes like this, and you're walking this way, and this is grass, most of you, instead of walking all the way around, most of you will instead cut through the grass, knowing that this distance is smaller than these two distances put together. You're not quite using the Pythagorean theorem, but you've got this idea in your head already about how right triangles work. We're just building on that. Okay, so now we're going to do one example from Khan Academy on using similar and congruent triangles, and it's this one right here. We are looking for the length of HD, so this is the length we're looking for. We know that part of it is 9, so if we can figure out what this bit is here, we can solve the problem. Okay, so once again, the most important thing to do in problems like this that look very complicated is to separate and simplify. Okay, we've got one triangle that looks like this. Okay, so we're going to take that triangle and we're just going to scoot it over and make it by itself. Okay, again, my diagram isn't perfectly proportioned, but that's okay. Now this small triangle has a base of x, right? That's right here. And it has a height of 6. That's that right there. The larger triangle looks something like this. And it has a base of 9. That's that right there. And it has a height of 27. That right there. So now that we've got our simplified diagram, we don't need the complicated diagram anymore. We can just look at these two, and hopefully it gets pretty easy. In fact, take a look at this. If I look at this 27 to this 9, it is being divided by 3, which is the same thing as multiplying by 1/3. That means the same thing. So for this triangle, we are also going to divide by 3, or multiply by 1/3. Well, 6 divided by 3 is 2. So 2 is our answer, right? Well, no. That 2 is only part of the answer. If we go back to the original question, we notice that we're looking for the length of HD. We found the length of HP, this small section right here. So we just add the two together. The length of HD, remember, when I don't put a segment bar up here, it means the distance between H and D, the numerical distance. It's not talking about the line segment, it's talking about the distance between those 2 points. And that equals 11.